For an elementary reaction to successfully produce products, the reactants must successfully collide to initiate the breaking and formation of bonds. So in summary, successful collisions must overcome the activation energy barrier, or energy required to activate the reaction, and the molecules must be oriented a certain way relative to each other. So here, for example, where carbon monoxide collides with oxygen, and the oxygens are facing each other, no reaction occurs. Whereas if the carbon is facing the oxygen, you get the formation of a carbon dioxide molecule and an oxygen left over, which would bond with the other carbon monoxide molecule to obtain two carbon dioxide molecules overall. Now, using the Maxwell-Boltzmann distribution, which describes the distribution of particle energies, we can qualitatively estimate the fraction of collisions with sufficient energy that lead to a reaction, and also how that fraction depends on temperature. So here, for example, if we have a lower temperature, then there's a narrow distribution of gas particle energies, and only a small fraction are going to overcome the activation energy to initiate the reaction. Whereas for the higher temperature, you have more gas particles that overcome the activation energy, because a higher temperature means a higher average kinetic energy of the gas, and therefore there are likely more collisions that have sufficient energy to yield a reaction.